Hello everyone, I'm teacher EJ. Welcome back to our YouTube channel. Today, I'd like to talk about past year question for NMOS 2023, which is about the butterfly model. Now everyone, let's have a look. So given the rectangle ABCD below, the area of triangle EBF is 20 and the area of triangle BFC is 23. So we have EBF, this is 20, and we have BFC, this is 23. If the area of the quadrilateral AEFD is x, find 20x. So AEFD, this is what we are trying to find, the value of x right here. So how do we solve this question? Oh, you can see that in this question, we want to find area of quadrilateral. But we are not given with any length, we are not able to calculate it. We just have the area of these two triangles. And it seems like there is no relationship between them. So how do we solve this question then? Okay, everyone. Now let's have a look at one example. Now let's see. We have this quadrilateral right here, and there is two lines DB and AC cutting through it, and it forms four different triangles. Now let's say if you want to find out the relationship between the triangle. Let's say we want to find out the error ratio between S1 to S2. Now, what would it be? Oh, we can see that this is actually the equal height model. So we say that error ratio will be the base ratio. And you can see that S1, S2, the base will be DO, OB. Alright, so we say that S1 to S2, it will be OD over OB. Now, how about the error ratio of S3 and S4? What would it be? Everyone, this is actually another equal height model. So S4, S3, it will just depend on DO and it will depend on OB. So we say that again, we will get that this is equal to OD over OB. Now everyone can see that our ratio right here, they are just equal. S1 over S2 is equal to S4 over S3. And in this case, if we do not want to write in the form of fraction, we can also try to cross multiplication here. We will get that it will be S1 times S3 equal to S2 times S4. In another word, we say that the product of the area for the two opposite triangles, S1, S3, is equal to S2 times S4. And everyone, this model right here is what we so-call the butterfly model. So in butterfly model, we have come up with the conclusion such that S1 times S3 is equal to S2 times S4. And just now we said that in terms of the words, we say that the product of the area of the two opposite triangles, it will be equal. Alright, everyone. Now let's take a look at our next example. Let's say, this is another figure right here. And you can see that, this is actually a trapezium. So everyone, inside this trapezium, actually there is a very interesting characteristic about S2 and S4. What will be the relationship between them? Okay, everyone, we say that we have a trapezium right here, and we see that, the line AD and the line BC right here, what is the characteristic? We say that there are two parallel lines. When we have two parallel lines, we say that, any distance between these two lines, they will be equal. And everyone can see that, although this is something that we know, but what's the relationship between S2 and S4? Maybe we cannot find any relationship now. But what if we try to combine another triangle together? Let's say we have S2 and S3. These two parts, we form one triangle. And we have S3 and S4 form another triangle. What will be the relationship between these two triangles? Everyone, we said that this is a parallel line. So, with the height of these two triangles, what's the relationship? There will be equal height. And you can see that they have the same base of BC right here. Equal height, equal base. So what is the relationship of the area? We say that the triangle ABC and the triangle BCD, they will have the same area. And everyone, since they have the same area, you see that ABC, which two parts they are made out of? S2 plus S3. How about DBC? It is S3 plus S4. So we say that these two parts, they are equal. And we can see that, S3 plus S2. This is S4 plus S3. In this case, we will get a conclusion such that S2 is equal to S4. And everyone, this figure right here, we also call this the trapezium butterfly model. And from here, we learn about one conclusion, whereby S2 is equal to S4. Okay, that's not the end. We take a look at another example. Now, everyone, let's say we have this triangle right here. And now, let's say we make it even bigger. Oh, we form this triangle. Let's say one side of it, the ratio is 1 to 3. Now think about it. How about the ratio of these two sides? What will it be? We say that it will also be 1 to 3. How about these two parts? It will also be 1 to 3. And when we say that these two triangles, they have the same angle, we call this kind of triangle the similar triangle. So when we have the similar triangle, it will come out with the conclusion such that the ratio for the corresponding side, it will be equal. Now everyone, let's look at our figure right here. So based on what we have learned just now, let's say, our ABC here, we said that this is A, this is B. And you can see that, these two angles, what's the relationship? That is the same angle because this is a vertical angle, right? How about these two angles? Because we said that ADBC parallel line. So if they are a parallel line, these two angles will also be equal. And how about these two parts? It will also be equal. Which means that our triangle ADO and BCO, they are the similar triangle. If they are the similar triangle, now my question is, AO to OC, what will be the ratio? It will also be A to B. How about DO and OB? It will also be A to B. And everyone, now, let's say we want to find out the relationship between the triangle now. Let's see, how about the triangle S1 to S2? What will be their area ratio? We see that this is just one equal height model. So we say that area ratio equal to the base ratio. We have the base ratio here, A and B. It is equal to A to B. Now, how about if I want to find out the area ratio of S2 to S3? What will it be? Everyone, again, another equal height model. It is equal to the base ratio, again, A, B, A to B. So now everyone, now that we have these two ratios right here, if you like to find out the compound ratio S1 to S2 to S3, what will it be? You see that for this two ratio right here, we have S2. S2 is B, but S2 over here is A. So to make it as a compound ratio, we need to unify the unit. We need to make it to be the same unit. So what do we make it into? We just have to make the both S2 to become A, B. Which means that in our first ratio right here, to make S2 become AB, what do? We multiply the whole ratio with A. So we have A times A, we got A squared. We have AB. Then over here, we have to make A here to become AB for S2. What do here? We multiply by B. So which means that here we have B times B, which is equal to B squared. Which means that these three ratios right here will be equal to A squared, BAB, and B squared. And then we still have one more triangle, our S4. What will be the ratio for S4? We learned just now such that S2 is equal to S4. Therefore, we will get that the ratio of S1 to S2 to S3 to S4, it will be equal to A squared, AB, B squared, and then it will again AB. Now, one last question. How about the area of the whole figure? What will be the ratio of it? We say that it will just be the summation of all of the four triangles. We will have A squared plus AB plus B squared plus another AB. It seems like a little bit complicated. But everyone, actually, this can be written as a form of A plus B bracket square. This is what we so-call the square of a sum. Right? I will not talk more about this. You will just know that this will be equal to A plus B squared. So everyone, now that we learned about the trapezium butterfly model, we have come up with another second conclusion, whereby we can find out the ratio of our area right here. We say that S1 to S2 to S3 to S4 to the area of the whole figure, it will be A squared, AB, B squared, AB, and the whole figure will be A plus B bracket square. Alright, and then remember that there is one thing that we learned just now from our first example. Actually, in the trapezium butterfly model, the conclusions such as S1 times S3 equal to S2 times S4 is also applicable here. Alright, now that we learned about this, let's go back to our question. Alright, so in our question right here, can we see the model that we learned just now? Oh, actually from here we see there is two lines crossing each other. To form a butterfly model, we just have to connect the line from E to D. And from here, is there any area of the triangle that we can find out? We know that the triangle EFD, BFC, they will have the same area. Both of it will be equal to 23. Alright, so let's label it on our figure. But now we still have to find out the remaining AED over here. How do we do that? Now it seems like currently we are not able to calculate this. How about DFC? Do we able to know what is DFC? Oh, we know that the area of the two opposite triangles, the product of them, that will be equal. So we can find out the area of DFC by multiplying 23 times 23 divided by 20. Oh, we'll get a fraction 529 over 20. Now let's also label it on our figure. But again, how do we find what is AED? Oh, F1. You can see that in this figure. Oh, we cut it half. This triangle right here will be equal to the area of the other half of it. Which means that AED plus 23 plus 20, what does it equal to? It will be equal to 529 over 20 plus the 23. From here, we can calculate the area of AED. So we just have to use 529 over 20 plus 23. We minus out these two areas. We will get an answer will be 129 over 20. So now we have found out the area of these two parts. To find out what is x, you just have to add them up. So for x, you will just have 129 over 20 plus the 23 that we found it here. We will have 589 over 20. And in this question, we want to find 20x. So we just have to multiply by 20. You'll get that the answer will be 589. This will be our final answer. So now let's summarize what we learned from this question. First thing first. Oh, in this figure, we learned about what we so-called the butterfly model. From this, we have come up with one conclusion. What is it? We know that the product of the area of the opposite triangle, that will be equal. And then, we learn about the second thing. This figure right here. We call this model the trapezium butterfly model. So, what is the first conclusion that we get here? We know that S2 is equal to S4. Other than that, what do we know? We also learn about the area ratio for all of the triangle and the whole figure. Although it is not applicable in our question right here, but it is very, very useful for you to solve the other question. Alright, and finally, in the trapezium butterfly model, you have to know that the opposite triangle, they will also have the same area. Alright, so everyone, now you can try to do this practice question and you can leave your answer at the comment section below. Alright, so you may join our WhatsApp group for more information about our activity. I hope you enjoyed this video and don't forget to subscribe to our YouTube channel. See you in the next video. Bye bye.